Hello everyone, this is John Hashmet and welcome to Physics Simply. In this video I will be solving the paper 2 exam for October-November 2020, variant 2. So let's get started. Question 1 says the diagram shows a measuring device. For which measurement is this device suitable? This is a screw gauge micrometer. It's used for very small measurements. So A says diameter of a cylinder of aluminium about 20 centimeters. This is too big for a micrometer. Distance between two molecules. This is actually too small for a micrometer. Length of a rod of iron of about 1 meter. This is too long also. So it's D, the thickness of a sheet of copper of about 1.5 millimeters. This is okay. Question 2 says the graph shows how the speed of an object varies with time. Which row describes the motion of the object at times p? So at p, this is constant speed since the value on the y-axis does not change. So moving with constant speed. At q, the speed is increasing, so this is accelerating. So the answer is C. Question 3 says a concrete block falls vertically from an airplane. The concrete block falls into the sea and sinks. Which graph shows the vertical motion of the concrete block? So it's falling a large distance, which means it has enough time to has enough speed to experience air resistance, which means we're not moving with constant acceleration under gravity. We are moving with decreasing acceleration, so it's either C or D. But when the block hits the sea or the water, it decelerates greatly because drag in water is much greater than drag in air. So it's basically the same as opening a parachute. So it decelerates very quickly, and as speed decreases, drag decreases, so it's decreasing deceleration, not decreasing acceleration. So the answer is C. Question 4 says which quantity is weight an example of? It's an example of force, so the answer is B. Question 5 says which statement about the mass of an object is correct? It changes when the object is lifted further from the ground. No, it does not change. It is a gravitational force. The mass is not a force. The weight is a force. It is zero if the object is in orbit. No, the mass is not zero. It resists any change in motion. Yes, this is according to Newton's first law. If a mass is at rest, it remains at rest, or if it's moving, it moves with constant velocity if there is no resultant force on it. Question 6 says a rectangular metal block is 20 centimeters long. The cross-section area of the block is 25 centimeters squared. The mass of the block is 4,000 grams. What is the density of the metal? And the answers are all in grams per centimeter cubed. So the equation is density equals mass divided by volume. So we have the mass 4,000 and the volume is the multiplication of area, which is 25, and the height or the thickness, which is 20. This gives an answer of 8 grams per centimeter cubed, so the answer is C. Question 7 says the diagram shows a beam lying on the ground. NQ is lifted from the ground by the force F. NP of the beam remains on the ground. The length of the beam is 3 meters and its weight is 600 newtons. The center of mass of the beam is at G, 1 meter from NP, so the weight is acting at this point and it's 600 newtons, and we have an unknown force F, and we have the distances from P, which means P will be the pivot, and the 600 Newton is causing a clockwise moment and the F force is causing an anti-clockwise moment. What is the size of the force F when it just raises end Q from the ground? So we need the clockwise moment to be at least equal to the anti-clockwise moment. So we say that 600 newtons multiplied by its distance from P, which is 1, is equal to the force F multiplied by its distance from point P, which is 3. Then we divide by 3. This gives an answer of 200, so the answer is A. Question 8 says the diagram shows a stand. The stand holds a heavy mass above the bench. Which two changes would definitely make the stand more stable? So we lower the center of mass and we increase the base area. So lower the mass is correct, lower the mass is correct. And make the base narrower? No. Make the base wider? Yes. So the answer is B. Question 9 says a footballer kicks a stationary football. His foot is in contact with the ball for 0.050 seconds. The mass of the ball is 0.40 kilograms. The speed of projection of the ball is 25 meters per second. So this is the final velocity, and stationary means that the initial velocity is 0. What is the average force exerted on the ball by his foot? We can use the equation force equals change in momentum over time. So it's mass multiplied by the change in velocity divided by time, or mass multiplied by acceleration. So we have the mass 0.40, then we multiply by 25 minus 0, and then divide by the time 0.050. This gives an answer of 200 newtons, so the answer is C. Question 10 says a woman of mass 50 kilograms has 81 joules of kinetic energy. What is her speed? So the kinetic energy has an equation of m, the mass v squared, which is the speed squared. So we substitute, we have 81 equals half multiplied by 50 multiplied by the speed squared. So we make the speed the subject of the formula. So we multiply 81 by 2, then we divide by 50. So we move this by multiplication, then we move the 50 by division, then we get the root of this, since what we calculated was the speed squared, not the speed itself. This gives an answer of 1.8 meters per second, so the answer is C. Question 11 says, what is the source of the sun's energy? Chemical reactions in the sun's core? No, it's not chemical. Gamma emissions of the sun's core? No. Nuclear fission in the sun's core, or nuclear fusion? It's fusion for stars, so the answer is D. Question 12 says, to calculate the power produced by a force, the size of the force must be known. What else needs to be known to calculate the power? So power is equal to work divided by time, and work is calculated force by distance, then we divide by time to get the power. So the distance that the force moves, yes, we need that. The time for which the force acts, yes, we need that also, so the answer is A. Question 13 says, a researcher submarine is at a depth of 10,000 meters below the surface of the sea. The average density of the water above the submarine is 1030 kilograms per meter cubed, and the atmospheric pressure at the surface of the sea is 103,000 Pascal. How many times greater is the pressure due to the seawater than the atmospheric pressure? So first we calculate the pressure due to the water. Pressure equals rho gh, density multiplied by gravity acceleration by depth. So we have 1030, then we multiply by 9.8, then multiplied by the depth, which is 10,000. Then we divide that by 103,000 to get the ratio. How many times greater means we have to calculate a fraction. This gives an answer of 980 after dividing by the atmospheric pressure. So the closest number is 1000. So the answer is C. Question 14 is about barometers, which was removed from the syllabus, so you can skip this question, but I will solve it. The diagram shows a mercury barometer. Which height is used as a measurement of atmospheric pressure? It's from the top of the liquid inside the tube to the top of the liquid inside the dish. So the answer is C. Question 15 says, a student splashes water onto her face. Here are three statements about the effects. The water uses energy to evaporate. Yes. The water gains energy from the student. Yes. The face of the student cools. Yes. Evaporation causes cooling effect. Which statements are correct? All of them are correct. So the answer is D, P, Q, and R. Question 16 says, a bimetallic strip is used to control the temperature of electrical appliances. It is made of two different metals fixed together. The diagram shows the shape of the bimetallic strip before and after heating. So it appears that metal P expands more when heated, so it contracts more when cooled, by the way. Which statement is correct? Metal P contracts more than metal Q. That is correct, but not when heated. It's when cooled. Metal Q contracts more. No. Metal P expands more than metal Q on heating. Yes, this is correct. So the answer is C. Question 17 is about the thermocouple, so it was removed from the syllabus, so you can skip this question. It says a student writes 3 statements about thermocouples. They have a small thermal capacity, they respond very slowly to temperature, they can measure temperatures above 500 degrees Celsius. So the first one is correct, the second one is not correct, the third one is correct. Which statements are correct? So it's 1 and 3 only, so the answer is C. Question 18 says 4 blocks are made from different metals. Each block is heated for 5 minutes with an identical heater. Assume there is no energy loss from the blocks. The table gives the masses of the blocks and the temperature rises. Which metal has the highest specific heat capacity? So we have the equation Q equals mc delta theta or delta T. If we use the same time using the same heater, we have the same energy. And we want to calculate the specific heat capacity, so it's energy divided by mass and change in temperature. So we need the highest specific heat capacity, so we need the lowest value for mass multiplied by change in temperature, which means we have to calculate the multiplication of all these values and see which one is the smallest. So 2 multiplied by 5 is 10. 2 multiplied by 9, that's 18, 4 multiplied by 5, that's 20, and 4 multiplied by 9, that's 36. So the lowest value for mass multiplied by change in temperature is A. Question 19 says, a scientist measures the air temperature at different heights from the floor in a cave. The results are recorded in the table. When it's 0, it's 10, 10, 11, 20 gives 13, 30 gives 14. So it appears that as you move upwards, the temperature rises. Why does altering the height affect the temperature of the air? This is due to convection currents. The molecules in warm air have less energy. That's not correct. The molecules in cool air are further apart. No, they are closer. Warm air is less dense. Yes, so it rises. So the temperature at higher altitude is warmer. So the answer is C. Question 20 says 4 solid spheres made from the same metal are heated to the same temperature. Which sphere initially loses thermal energy by radiation at greatest rate? So greatest rate of radiation happens when the temperature is high, or the surface has a dark color or dull surface, or when the area is larger. So diameter, that's about area. So we need the larger diameter, not the smaller one. And a dull surface, not a shiny surface. So the answer is A. Question 21 says, which row correctly describes light waves? They are transverse waves, and in transverse wave, the direction of vibrations are perpendicular to the direction of the wave travel. So the answer is D. Question 22 says, a radio transmitter broadcasts a frequency of 200,000 Hertz, kilohertz. What is the wavelength of these radio waves? So we can use the equation speed equals wavelength multiplied by frequency. So wavelength is equal to speed divided by frequency. And for radio waves, that's an electromagnetic wave. The speed is 3 times 10 to the power of 8. You should know that. Then we divide by the frequency, which is 200,000, or 200 times 10 to the power of 3. This gives an answer of 1,500 meters, which is C. Question 23 says, an optical lever is a very sensitive device for detecting small rotations. A lamp sends a narrow beam of light onto a small plane mirror attached to a shaft whose rotation is to be measured. The operation of the device is shown in plan view, that means from above. The beam from the lamp reflects from the mirror to give a small spot of light on a scale placed just above the lamp. The shaft and mirror rotate through an angle of 1 degree. The spot of light moves along the scale. So this is a scale, and the table shows the angle theta through which the reflected beam rotates and the conditions required for high sensitivity. For high sensitivity, we need this to be as long as possible to be easier to read. So we have to place the lamp as far as possible to make this distance larger. So if you put the lamp here and we have the same angle, so the lines are parallel, you get a larger distance. So that's more sensitive or easier to read. So we need to place the lamp as far away as possible. So we have D or B, and the angle of the reflected beam. So if this is normal to the mirror and the incidence ray has an angle of incidence 1 degree, the angle of reflection is also 1 degree. So the total angle is 2 degrees. So it's either C or D. So the answer is D. Question 24 says a student draws a diagram to illustrate the different sections of a longitudinal wave. Which labeled section is a rarefaction? So it's the part where the molecules are as far apart as possible. So it's B. Question 25 says the diagram shows white light passing through a prism. Which description of what happens as the light passes into the prism is correct? So it's a comparison between red and violet rays. So the red did not divert as much as the violet ray. So less deflection means less refraction or less change in speed, which means that the red will have the higher speed. So the speed of the red light is less. No. The speed of the red light is greater. Yes. The speed of the violet light is less. Yes. The speed of the violet light is greater. No. The other part of the sentence. And the red light is least refracted. That's correct. The red light is the least refracted. That is also correct. So the answer is B. Question 26 says a police car with its siren sounding is stationary in a heavy traffic. A pedestrian notices that although the loudness of the sound produced does not change, the pitch varies. So loudness does not change means that the amplitude is constant. The pitch varies means that the frequency is varying. So the answer is B. Question 27 says a piece of steel is slightly magnetized. It is hit several times with a hammer. Which effect will this have on the steel? The steel is placed parallel to a strong magnetic field that actually magnetizes the piece of magnet more strongly. So it's either A or B. Placing it in a weak magnetic field, which means it has no effect, but hammering with no magnetic field causes demagnetizing. So it loses its magnetism. So the answer is B. Question 28 says a student sets up 4 experiments using bar magnets and other metal objects. The N and S poles of the bar magnets are labeled N and S. Which pairs attract each other? So north and south, they attract each other. So this attracts. Iron is a magnetic material, so it gets magnetized by induction. So it will form an S pole and an N pole like this. So it will attract. Copper is not magnetic. And N with N, they repel each other, so they will not attract. So it's only 1 and 2. So the answer is A. Question 29 says which diagram represents the strength and direction of the magnetic field around a current carrying conductor? The direction of the current is into the page. So using the right hand grip rule with the thumb pointing into the page, the fingers are closing clockwise. So it's not D and it's not B. But the magnetic field gets weaker as you go further away from the source of magnetism. So the lines should not be equally spaced. So it's not A either. Spaces increase. So the answer is C. Question 30 says which quantity is defined as the energy transferred by a cell in driving a unit charge? That is voltage or potential difference or electromotive force. So the answer is B. Question 31 says there is a current in a variable resistor when a potential difference is applied across it. In which situation is the current increased? Decreasing the potential difference? No, you need to increase the potential difference or keep it the same, but decrease the resistance, not increase the resistance. So the answer is C. Question 32 says a student uses 4 ammeters P, Q, R, and S to measure the current in different parts of the circuit shown. Which 2 ammeters read the largest current? So it will be the ones right next to the power supply, since it will get divided into the branches. So it's P and Q. The current going into the battery and going out of the battery are the same. So the answer is A. Question 33 is about logic gates, which was removed from the syllabus so you can skip this question. It says which combination of logic gates gives the truth table shown. So 0, 0 gives 1, 0, 1 gives 1, 1 and 0 gives 1, only 1 and 1 gives 0. This is the opposite of an AND gate. So this is an AND gate, which can be made by placing an AND gate, then adding a NOT gate. So the answer is B. Question 34 says the diagram shows an AC generator used to power a lamp. The coil rotates in a clockwise direction, which means this part goes up and this part goes down. Which magnetic poles are X and Y? So we need to use the right hand rule, knowing the direction of motion. For example, on this part of the generator, the current is going into the page and the motion is upwards, which means the magnetic field is either to the right or to the left. If we use the right hand rule like this, with the middle finger going into the page and the thumb pointing towards the motion upwards, the index finger is pointing to the right, which means that X is the N pole and Y is the S pole. So the answer is B. Question 35 says a transformer is needed to convert the supply of 240 volts AC, that's primary, into 4800 volts AC, that's secondary. Which pair of coils would be suitable for this transformer? So the rule is NP over NS is equal to VP over VS, which is equal to 240 over 4800. This gives a ratio of 1 to 20 or 0.050. So we divide these values by each other to get the ratio of the number of turns, and we already have the ratio of the voltages. The first one, 50 divided by 1000, that's 1 over 20. That's already the correct answer. The next one is 1 over 200. The next one will be 20. The next one is also 20. So the answer is A. Question 36 says the diagram shows a coil of wire wrapped around a soft iron rod. The wire is connected to a DC power supply as indicated. The apparatus is in a region which is totally shielded from Earth's magnetic field. A small compass needle is placed at point P. In which direction does the end pole of the compass needle point? So the current is moving in this direction, and we have the magnetic field line which passes through P would be like this, which will be an oval curve. Using the right hand grip rule again, with the fingers pointing in the direction of the current, the thumb is pointing to the left inside the coil, so it moves like this and points to the right at P. In which direction does the end pole of the compass needle point? That's the direction of the needle anyway. Toward the bottom of the page, no. Left, no. Right, yes. So the answer is C. Question 37 says, which statement is correct for the nucleus of any atom? The nucleus contains electrons, no. The nucleus contains the same number of protons as neutrons, not always. The nucleus has zero charge, no, because it has protons which are positively charged. The nucleus is very small compared to the size of the atom, yes. Question 38 says the symbol represents a nucleus of zinc. Which row gives the numbers of protons and neutrons in this nucleus? So the number of protons is the proton number at the bottom, so it's 30, A or B. And the number of neutrons is not 68, it's 68 minus 30, so it's 38. So the answer is A. Question 39 says the diagram shows a beam of beta particles which are negatively charged passing through a strong electric field. In which direction will the beta particles be deflected? So they will be attracted towards the positive charge, so it's upwards towards the top of the page. Question 40 says which equation represents the beta decay of lead 209? So the beta is emitted after the reaction, so it's not on the left side of the arrow, and beta particles actually increase the proton number, do not decrease the proton number, since a neutron is changed into a proton, so number of protons increases. So the answer is C. This is the end of the exam. I hope you enjoyed this video and found it useful to you. I will see you in another video.